I am Dr. Mike Wofsey of Golden, Colorado. I am a physicist. My work is in mesoscale dynamics applied to epidemiology and public health. There's a perception borne out by data that air quality has gotten better in North America and Europe since the 1960s. Our air looks visibly cleaner. And yet, certain lung-related disorders like asthma and chronic obstructive pulmonary disorders seem to be on the rise. Why is there a disconnect? It seems that these small particles, some people call them PM2.5s, is a common name in the news, or accumulation mode particles, even smaller than those, submicron particles, are a major health culprit. Because they're so, unlike the large particles that are visibly dirty and gross, the small particles, largely invisible, are able to penetrate our lungs in a way that the large particles couldn't. They can get into our alveolar region, they can penetrate the blood barrier in some cases, they have a very large surface area per unit mass, and they're reactive. They seem to be causing us some health problems. Just because they're tiny doesn't mean they're not dangerous to us. This research finds, through some applied thermodynamics, that in a bimodal pollutant particulate distribution, the camel's hump distribution, where you have small particles which tend to aggregate or condense out of the air, and large particles which tend to condense differently or maybe sinter off of the source, have an effect on each other. And what the large particles do in their life has a strong impact in what happens to the small particles. Unfortunately, in our really well-driven effort to clean the air over the last 40 years, we've removed these easy-to-remove large particles. And while that made the air look very clean, in some cases it may have removed an aggregation center for the small accumulation mode PM2.5 submicron particles. We had a lot of little stuff that we need to remove from the air that doesn't like to come out on its own, and we remove the thing that it likes to stick to. This research looks at that. It's taken some numerical analysis and applied theory to figure out these modes of operation, and we come out with a surprisingly simple relationship between the potential aggregation of small and large particles and their diameters. It simplifies to a beautiful little, very easy to memorize formula. Thank you very much. We hope you enjoy this work.